Question 13. What point of methanol at 25 millimeters of mercury if its normal boiling point is 64.7 degrees Celsius and delta H VAP is equal to 35.21 kilojoules per mole? So this can be answered using the Clausius-Clapeyron equation. Which states that the ln of your final pressure over your initial pressure is equal to delta H VAP divided by R times 1 over T1 minus 1 over T2. So the value of R is the ideal gas constant, which is 8.314 joules over moles times Kelvin. P1 is given in the equation, or in the question, 25 millimeters of mercury. P2 will just be equal to the pressure at standard temperature and pressure values, which is 760 millimeters of mercury. T2 is equal to 64.7 degrees Celsius, but we are going to convert it to Kelvin just to make everything in the same units. So we're going to add 273.15 to 64.7 to give us 337.85 Kelvin. And then finally, delta H is given as well, 35.21 kilojoules per mole. Okay, so let's plug in all the values. Ln 760 divided by 25. And then I'm going to convert the delta H to joules, just because our R value is in joules as well. So just multiplying this by 1,000, we have 35,210 joules per mole divided by R. One over T1 minus 1 over 337.85 Kelvin. Okay, so let's try to simplify this. So I did the calculations in advance. And we're pretty much just solving for T1. And you should get T1 equal to 365.5 Kelvin. Okay, so the junior tutor used the Clausius-Clapeyron equation as well. They showed how they got all of their values, plugged it into the equation, and also got 365.5 Kelvin. So the solution is correct. I think I have time for one more question.